Biogeography includes many different subfields. There's no fixed number of subfields, but there are some that tend to see more dedicated work or representation. If you've heard of biogeography before, it might have been in the context of island biogeography, also called insular biogeography. This area began with work from the ecologists Robert MacArthur and Edward Wilson, more often seen as E.O. Wilson, who were interested in predicting the number of species that you might find on a newly created island. Later, Wilson and Daniel Simberloff actually tested the theory of island biogeography by fumigating a mangrove island in the Florida Keys, then seeing how quickly arthropod species repopulated. The basic idea is fairly straightforward. The larger an island is, the more species will settle there, and the closer an island is to a mainland from which species can emigrate, the more species will end up there. Smaller islands and islands that are farther from mainlands tend to have smaller numbers of species. We'll talk more about this later in the semester. Paleobiogeography is a subfield we'll talk about all through the semester. Paleobiogeography is concerned with investigations into the relationships between past organisms in times and places that no longer exist. For example, you may have seen this figure before, probably as an illustration of plate tectonics. For now, it's important to note that the figure shows you not only extinct organisms, but the time that they lived, the Triassic period, which will pop up in the caption in just a second, and the organization of the continents that we now know at that time. Historical biogeography is a related subdiscipline that attempts to reconstruct the origin, dispersal, and extinction of taxa and biotas. An aside here, a taxon, plural taxa, is a taxonomic group in a rank, so it could be species, genus, family, class, so on, while a biota, plural biotas, is the life in a particular region and or time. Timescales in historical biogeography tend to be longer, on the order of thousands of generations, so that we can see evolution at work, but maybe not as long as the timescales in paleobiogeography. This figure combines historical biogeography with another subdiscipline, human biogeography. For now, note that the figure shows 3 taxa in the Homo genus, as well as timescales in the tens and hundreds of thousands of years. Phylogeography is one of the newest subdisciplines of biogeography and is concerned with the analysis of the evolutionary interrelationships of populations of species and of closely related life forms based upon their gene sequences in relation to geographic space. If it turns out that you're interested in biogeography, but you'd rather do a lot of computer-based work, this might be the field for you. These figures show a phylogeographic analysis of giraffes. These comparisons take into account geographies, physiologies, in this case spot shape and placement, and genetics in order to understand evolutionary relationships between giraffe subspecies.